Hello? Oh, hi. Okay. Good morning, everyone. It's nice to see that a lot of you came to join this session tonight. I'm really happy to welcome you to the DNS working group session, and especially I'm very happy that I'm doubly represented today thanks to Willem. Yeah, so the first thing I would like to announce is that tomorrow, so Thursday, we have a BOF at the end of the sessions, which is about DNS authoritative servers and whether we would need a best current practices document and how that should work. That is a panel with 4 people. And I would like to invite you to join this discussion and help us find some conclusion about that. Next up, Phil Regnault would like to make a short announcement about DNSORG best current practices. Is he in the room already? Ah, perfect. Microphone or here, however you like.
Right, so hi, Phil Regnault, incoming for a while now, president at DNSORG. And just that you mentioned, operational BCPs is great timing. We've had, I think some of you might know, at ORG 44 in Atlanta, we had a BCP discussion, a panel, and it seemed there was general consensus. It was a good idea to have the ORG community take a look at DNS operational best practices. And therefore, we're looking forward to this panel tomorrow. And for those of you who are interested in this, please come and talk to me. We're kind of now moving forward on this and having a Mattermost discussion channel on the DNSORG Mattermost. And the people that were on the panel back then, are being invited to contribute and see how does this effort take shape and what should be ORG's voice and involvement in this. So again, come and talk to me if you're interested during the breaks or whatever. And then also tomorrow during the BOF, the panel session will be also very relevant for that. So thank you.
Thank you. One more topic before we start with the presentations. As a lot of you will probably know from the mailing lists, I am stepping down as a DNS co-chair for personal reasons. And we have found a person to join the team, which is Yevgenia Nosik, and we will join her. Hello. We cannot hear you so far. Can you?
Thank you. I'm very happy to become a new co-chair and see you all at the next RIPE meeting. Thank you.
So Doris, that also means that you will be leaving us. And we're very sorry about that. You have been a really great co-chair. And as a token of our appreciation, we also have a small present for you.
Oh, thank you. Oh, thank you. Yeah, so for whoever still has doubts, I'm not leaving because of the team. You're amazing. All right. Now off to our first speaker, Ondřej Surý. He's going to tell you about post-quantum DNSSEC.
So hi, I'm Ondřej at ISC. So I hope you had a good party and you took your partner for a spin. It was post-quantum joke. There were some previous studies and on the post-quantum use in DNSSEC, and so I finally wrote my final draft for my thesis, and then I found some issues with it, so I'm still working on that. But I included more than just the Falcon that has been already approved by NIST, but there's additional digital signature scheme round 2 running right now, and there are some interesting algorithms that might be usable for DNSSEC. So I like looked at all of them and then just picked some that might be suitable and then tested them. So there's these are the extra one. There's Hawk, yeah, this joke on Falcon, also lattice based. So I'm not cryptographer, I'm crypto plumber, so I don't understand any of the math. So there's SQI sign, which is really nice because it's very small, but it has like problems we will see. Mayo, it's oil and vinegar scheme, and NTREG, which is not in the NIST, but it looks like the authors were thinking about like making Falcon smaller. So these are the sizes. As you can see, the SQI sign is the smallest, has the smallest public key, has the smallest signature. Then comes the Hawk, 256, but this is at the challenge level. They have this in the paper, like this is NIST level 1, and we give you a slightly less, like slightly smaller parameters, and we challenge you to break it. So this is a challenge level, so I don't know how much secure it will be in the end, but it might be suitable for the DNSSEC because, you know, our needs aren't the same as, you know, like 20 years of storage of the secure data in the US government. And then, you know, Mayo has a small signatures. This is the third one, and NTREG is like small public key, but that doesn't seem to be so important. So implementation status. So I also like implemented Falcon as well. So there's like quite good implementations. Hawk is like, well, like thank you the authors. This is neat little code meant for embedding. It was very easy to embed. Not so much for the other ones. The SQI sign and Mayo, the teams are mostly focused on the NIST challenge. So they are not suitable for any external use. This is just like benchmark. So I just had to mesh it, the CMake project into building shared libraries. And well, it's horrible, the current state of the code. And I think the cryptographers should not write code, and software engineers should not do crypto. But so, and NTREG, again, not a shared library, and it's work in progress. There are some bugs in that. I have some like machine that I disabled hyperthreading, turbo boost. So from 22 cores, I was left with 6. But it's for the stability of the results. There's a neat little tool called Hyperfine that runs, you know, the command you give it in like several repetitions and do the, you know, the mean and the sigma. And, you know, I'm using only the reference implementations, not the optimized ones. So there are several branches, each for the algorithm, and then I had to, like, I bumped some EDNS buffer sizes to be bigger. So for comparison, I'm also using that for the classical cryptography. Times for key generation, not so much important, but as you can see, the RSA is the slowest one. And it's also, you know, the standard deviation is like weird, but I've been told that this is normal for RSA. So signing. Signing is not that much important for normal use, but there are some cases like online signing or like huge zones like .com, .org, something where the, you know, it matters. So as you can see, the Hawk is really nice, and the SQA sign is really nice on the size, but it's very, very slow. It's like 2 magnitudes slower than the rest of them. The message sizes. So the orange one doesn't fit into the increased buffer size. The yellow one doesn't fit into the like the EDNS flag day sizes. It's 1232. So is it a problem? Well, one more slide on the verification times. Again, the SQI sign is very slow, and Hawk is even faster than, you know, existing algorithms. So for the resolver testing, we have at ISC we have this test bed where we combine the GitLab CI and the DNS shotgun. And I set it up a custom root server for hosting root zone signed with these algorithms. and the results. So ECDSA, I included all the classical ones as well. So this is quite small. So the blue one is always the baseline. So this is the like normal root zone, normal algorithm, and the orange one is the algorithm that I've been testing. So the top two pictures are the reverse histogram pictures. I hope you've seen them before, but basically you want everything to be to the left and to the down. But as you can see, these differences are mostly like noise. Same for ED 25519. Now, Falcon. As you can see, there's and that's what I'm looking at. The difference is because the signatures are larger and there's a fallback to TCP for some of them. And this is just a root zone signed with the Falcon, not anything up in the hierarchy. So this is quite a large effect, because if you look at that's your top left picture, can I use it as a laser pointer? No. So the bottom line means that everything has been answered under like 1 millisecond, and the difference is between like 15% till hasn't been answered under 1 millisecond, and it goes up to 30. So the difference is between 85% has been answered under 1 millisecond to something like 70 or 75% only. So this is quite a difference. And also these memory spikes are weird, but that could be also a noise. Hawk, again, it looks like no difference. The top right might be some noise there, but this is like, it's been tested on a real internet. Okay. Does it? Oh, okay. Okay, this might be just a noise because it's it's a real internet, So Hawk 212. Anyway, again, it looks like it might work, It's slightly slower, but nothing, this could be also a noise. SQI sign, yeah, that could be a problem. But, maybe we need to have a choice. Like, does it have to be like that fast or secure? So security speed, maybe we will have to make some compromises. And one thing that I need to say about this testing, this is real world data, but it's not like attackers' data. So this is there's more research coming that I plan to do, like look at, I'll speak about that. So this is the normal data graciously given by one of the ISPs that might be even here, anonymized. So the SQI sign is small, but the crypto difference, you can see at the CPU, which is bottom left. At the beginning, there's the CPU goes up, and there's a difference. So Mayo has a nice property. It has a larger public key, but the signatures are smallish enough for DNSSEC. And look, it looks nice. Again, untrack. Again, it might be a choice. But yeah, more research needed. So for NTRAC, yeah, so authors talk to me. That doesn't happen so often with these algorithms. But the multi-threading is broken. So if I'm signing anything, I need to just use one thread because otherwise it's so slow. It's slower than anything on Earth because there's some contention happening. The signing API is confusing, and I reported this to the authors, and it uses own random byte generation, which needs to be initialized, which I discovered by just like, I generated the keys and it had some key tags, and then I just purged it and generated again, and oh, they are same. So I found out that they were not initializing the random state internally. You need to do externally. For SQI, I finally managed to download .org zone, and I'm also signing it for like comparison sizes for my thesis. And after 8 hours, it ended up with floating point exception and core dump. So there's still some work to do. So for the future work, I need to test it at different levels of DNS hierarchy. I do have access for the centralized zone data store, the CZDS for MyCAN. Maybe use more algorithms. You know, there's still the NIST competition ongoing. Look at the pseudo-random subdomain patterns. So how does it look when attacker will try to attack signed domain with these algorithms? Then try something like forced rekeying, so SMOID TTLs for the DNSSEC keys. Implement the NSEC-free aggressive caching. Maybe we will have to just drop the opt-out from NSEC-free because of this, so we can, you know, deploy the NSEC-free aggressive caching. We also have the systemd trace probing already in bind code, and I can just like add probes around the crypto operation to see how it affects the resolution, and maybe use the optimized implementations. But there's, you know, for example, for SQI signed, I found out that they use some assembly that's not position independent code, so you can't make them shard libraries. So, you know, we need more implementations from people who are actually software engineers and can code a nice C code. So thank you. Do you have any questions?
Jeff Houston, APNIC, thank you for that presentation. I kind of am mystified as to why though. You said earlier, and I understand this from NIST as well, that the evolution of quantum computing says at this point, somewhere around 10 to 20 years from now, we might see deployment of these kinds of machines at a level that basically breaks existing crypto. Agreed. And if you want a secret to last for 20 years in today's world, then this kind of stuff is now timely and in some areas necessary. What puts the DNS in that mode? What part of the DNS needs to be a secret, or DNSSEC has an innate requirement to be a secret 20 years from today? I'm like, does anyone use 20-year expiry times in their caches? I'm like, what's going on?
I absolutely agree, and I wanted to say that. Thank you for bringing this up. My conclusion from all of this is that we should wait this out. So because there's still like a lot of research ongoing, and we should talk to NIST though, and this was actually suggested by the NIST guy who was at the post-quantum site meeting in Bangkok, that we should talk to them about our requirements for the post-quantum cryptography for DNSSEC, because their focus is elsewhere, and we should bring their focus to our needs as well. But I absolutely agree, we should wait this out because there's no urgent need to have this.
And one further comment, it was unclear in your presentation if you were querying your signed root zone for names that existed or names that didn't exist. Because the NSEC answers, as we know, are massively big. The positive answers, by comparison, are tiny.
Yeah, I can send you my thesis. I do have this in the future research. You know, it already has 100 pages, so I didn't fit it in.
Send it to me, I'll read it.
But I absolutely agree. That's one of the things. That was the thing I was talking about. I should try the pseudo random subdomain attack on the sign zones. which would include the NSECs.
Yeah.
Yeah, absolutely.
Thank you.
But yeah, it already has 100 pages.
Hi, this is Ulrich from ICANN. Well, I agree that we shouldn't deploy it today, but then I say, well, crypto agility is actually a thing, and DNS doesn't have the best track record of that, and so we cannot wait 19 years and then deploy it, because then we will be a little bit late. So I think we need to look into this, and then at some point start rolling it out, because it will take a lot of time, many years, and so I think this is really good work, and
I think these are two different questions. So we don't. So I think that what Jeff was asking was why we need to deploy this now. We don't, but we need to research this, and I'm trying to do that, and getting my master's as well.
Okay. Do we have any more questions? No? Okay, then I would conclude this. Thank you very much, Ondřej. And our next speaker is Marc van der Waal, and he's going to be talking about SPF DKIM at .fr. The floor is yours.
Hello, everyone. I am Marc van der Waal from FNIC. I'm an R&D engineer at the Registry of .fr domains. And today I'm going to talk about my research that I've been doing for over 2 years now about the adoption of SPF, DKIM, and DMARC within .fr domains. So first of all, what is it about? Well, you know probably that email has been notoriously easy to forge, because there are no real checks on the email headers and sender addresses especially, which leaves the gate open to all sorts of abuse and shenanigans like phishing and extortion emails you've probably had in your inbox. So in order to make it more difficult, 3 mechanisms have been devised: SPF, DKIM, and DMARC. So with SPF, you list the email servers that are allowed to send email on your behalf. With DKIM, we introduce digital signing of email headers and body. And finally, with DMARC, DMARC uses the results of SPF and DKIM to decide on the fate of an email. Also, as a sending domain, you can specify the action to be taken when an email fails SPF and DKIM simultaneously. So how are things currently going with .fr? And I see that PowerPoint has been messing with my statistics a little bit. Well, we have quite a bit of an increase in the adoption of SPF. We were about 56%, I think, in 2023, if I remember correctly. But DKIM and DMARC have been increasingly growing, so that's nice. But we're still a long way from widespread adoption. So as I said, with DMARC, in your DMARC policy record in the DNS, you can specify the action to be taken when email fails SPF and DKIM simultaneously. So these are the proportions of the 3 policies. None means do nothing special. And so I distinguish between those that had no email address for receiving the automated feedback reports that you can also have with DMARC, and those who do. In the latter case, it's called monitoring mode. And so we have quarantine, which means in this case, in case of email that fails SPF and DKIM, send it to the junk folder, and reject means reject at the SMTP level. So we see some big shifts in proportions, especially the P equals quarantine. Now, how can we explain it? This is the job of the next figure. Well, so The advice that you usually hear is when you're deploying DMARC is start with p equals none, but do look at the reports you get. And once you're confident enough that all your email passes authentication, then switch to p equals quarantine or reject. Now, as we can see, the big increase in the enforcing mode policies actually comes from brand new deployments of DMARC and not so much from deployments that started with p equals none and then switched to something more strict. And this happened 2 years in a row, so I thought it was quite interesting to show that the evolution in time of DMARC deployments like this. Anyway, looking at over 4 million domains, there are some interesting configuration mistakes that you sometimes see. The first example are overly permissive SPF policies. So you can shoot yourself in the foot by accidentally allowing everyone to send email on your behalf. And there are 3 ways of doing it. One is by ending your SPF policy with +all instead of -all. The second way is by fat fingering a /24 and turning it to /2. And the third one, well, I have no idea what happened, but this guy seemed to really like IPv6. Also, the downside of asking people to put things in their DNS is that they sometimes don't understand what it's supposed to be. So when you have an SPF policy, you should have exactly one. And so when you're outsourcing your email to a different company, like for mass emailings, and that company tells you to put this TXT record in your DNS, and then you go to a different company for a different emailing campaign, they tell you to do the same, you end up with several SPF policies if you don't understand what it's all about. Now, still with SPF, SPF policies live at the apex of the domain. So they have to contend with other TXT records that you also find at the same area, especially those Google site verification TXT records. And well, here I was trying to look for the SPF policy of this domain. Can you see it? Oh, no, I'm sorry. I should have zoomed out a bit. There it is. So yes, this DNS response has 80 TXT records. It's about 3 kilobytes in size, so there's no way it's going to fit in UDP. And well, if SPF were to be specified today, it would probably be at _SPF.domain.example, but it's too late to fix it. But we can probably fix those domain verification challenges. So there's a nice IETF draft. And we can probably all try to put these domain verification challenges in an attribute leaf instead of at the apex. Now, as for DMARC, something I think will be very .fr specific are DMARC configurations where keywords use French terms. Now, I was wondering why. Well, the answer is easy. Web tutorials that were machine translated, but not proofread. So obviously, the code examples shouldn't have been translated. Okay, so this screenshot actually comes from a presentation I did 2 years ago. And someone from the audience searched for the exact text and reached out to the website, and it was fixed 1 day later. So fortunately, these tutorials do get fixed. However, I tried reaching out to a different website, and I had to be much more patient and wait 6 months until they finally fixed the typo. Now, finally, I'd like to finish this presentation with the subject of park domains. So park domains are domains that you purchase for some reason, but you don't do anything with it. Maybe it's a defensive registration, or you have some project, but you tend to forget about them. And what sometimes happens is, well, these park domains, they don't have an SPF policy, they don't have DMARC policy, or or they have some incomplete configuration, and the domain gets used as a sending email address in phishing campaigns. So in one case, I saw a domain that was used in a phishing campaign, unbeknownst to the domain owner, and they had an SPF record, but no DMARC equals reject. So it wasn't rejected. And the thing is, when sometimes you park your domain, you park it with a company that asks you to change the name servers of your domain. And so you lose control over the zone file contents. So if they don't have the appropriate SPF, DKIM, and DMARC configuration, your domain is at risk of getting spoofed. So if you park domain, be sure to check the configuration and make sure that nobody can use it for nefarious purposes. All right, that's all I could cram into 10 minutes. Thank you very much. If you have any questions, let me know.
Hi, this is Ondřej, I see. I work for .cz before, so my question would be, do you have any classification about the .fr domains? Like these have some content and these are just parked and you know, cross match this with the policies?
Yeah, about that. So I've done previous studies in 2023 and 2024 where I did try to pick out domains that had content versus domains that were parked, but it turns out our classifier wasn't that reliable. So for 2025, I left it out, sadly, but it's a big subject by itself. It could be worthy of a lightning talk.
Hi, Greg Choules, also ISC. In a previous life, I had to try and sort this stuff out for the company that I worked for. And I think it's notoriously difficult when there's not a great deal of good information on, you know, what is good practice to do. Like you showed, people just stuff things in because they don't know what they're doing. I think there might be a case for better information dissemination to people who have to do this kind of stuff, you know, so that they can have the right kind of guidance to say, you know, this is the kind of thing you should do, rather than just blindly, you know, person A says, put it in DNS, person B puts it in DNS, and they tick a box and go away and think it's all sorted. And by the way, I hate include.
Yeah, thank you. I agree. And it's been notoriously hard to find good practices on SPF especially, so I've tried to compile my own.
Neil O'Reilly, much of what Greg said, I don't have a strong position on include, however. But part of the thing that needs to be put into the best practice from the point of view of an artisan who runs his own artisan mail server is indication of what can break if you haven't understood things properly. Because part of the obstacle, at least from this postmaster, is if I do this, will my wife's mail break? And that's not acceptable.
Someone who runs his own mail server also for personal email and my spouse's, I wholeheartedly agree.
Okay, are there any more questions online maybe? No? Okay, then thank you very much, Marc. And our next speaker is Asbjørn Tønnesen. He will talk about the best current practices for DNS filtering. The floor is yours.
Hi, sorry. Yeah. So why would we do DNS filtering? Both for legal reasons. In the EU, for instance, there are some sanctions against Russian media and other sites. And then we also have pirate sites like the Pirate Bay and other torrenting sites that also get blocked in some jurisdictions. And then in Denmark, at least, we also have some product safety things, and we have some gambling legislation. Then in some providers' networks, there also is some security filtering like malware or phishing domains that can get filtered out. In some cases, this is mandatory, and in other cases, it's an opt-in thing that people can opt out of. Oh, that's the wrong button. So how this is often done is using response policy zones. And then you could respond with an NX domain to a filtered domain, right? However, in some jurisdictions, we also need to show a blog page explaining why this is happening. Whereas if we just did the NX domain, people just could not connect to server error in the browser. This thing with the blog page might have worked great 20 years ago when everything was HTTP and we could spoof everything all over the place. But today there are some issues with that. And therefore, these pages are not really, even in places where they're mandated, they're not really seen by anyone. Because if you follow a link from HTTPS, then it will just give you a connection refused message in the best case. And in the case that the blog server is listening on HTTPS, you'll get a certificate error. But normally you would use a separate IP for this, where you'll reject HTTPS connections. So maybe we need something a little bit more modern than this. And also the specific HTTP status code is not really implemented, except for a few test cases. So one of the things that we could solve this with is that there's an RFC called Extended DNS Error Codes that defines 4 different error codes. So one of them is forged answer, which means that you reply a CNAME or a record or chord A, and it doesn't specify which reason it's blocked for. And then there are some that can only go together with an NX domain that are blocked, censored, and filtered. So blocked is if it's a mandatory policy in an ISP setting, it's not that common. In an enterprise setting, it would just be that the corporate policy forbids you to visit the site. So it's a decision taken on the entity that is doing the blocking. Whereas in censored, it's a legal mandate that you have an external requirement that you need to block this. For instance, in EU, we need to block rt.com. And in the filtered case, it's these kind of opt-in security, malware, phishing filters, where it's the client doing the DNS request that have requested that the blocking is done. And supposedly, sometimes it's enabled by default and you have to opt out. Other cases, it's an opt-in thing. But the basic thing is, if it's the filtered error code, you should be able to opt out of it. It could also be parental control or similar stuff to that. And of course, these EDE error messages, they are propagated through the resolvers, so that if you have a CP device that requests from an upstream resolver, it will propagate this error all the way to the client, right? No, it's an implementation detail, but the RFC says that it may propagate, so it's very weak, and in practice, it doesn't happen. So we probably need to work a bit more on that before we can really replace the HTTP block pages. So an example of a request with an EDE code could look like this, where this is a test bed we made during the DNS Hackathon in Rotterdam that has recently been upgraded to have some more different response types, and is now based as an authoritative server running with canned DNS, which you'll hear more about in the next presentation. But basically, you have the error code and you have an extra text field. So the extra text field can contain whatever you like. It's a free text field that supposedly should be able to be shown in the browser, saying this page is blocked due to these EU sanctions or whatever. I have found some cases in the wild where it just says blocked due to EU sanctions. But there's only a very few cases of this. So IDE codes are currently not possible to set with RPC in unbound or unbind, and DNSDist can set them but not set the extra text. But DNSDist cannot do RPCs. DNSMask would need to propagate this on CP devices for it to work in reality. And stop resolvers would need to propagate it to the browsers, and the browser would need to implement error pages for this. So we are still a long way off having a viable alternative to the block pages in order to inform users what is going on. So there is a structured DNS errors draft in the ITF that has just been last called. And that basically tries to change the extra text field to be an IJSON field with some specific parameters. And it also tries to define some of the initial keys for that registry. And some of those keys are also free-form text that will not be localized. Whereas many of these blog pages are dual language, especially for the ones in Denmark. We have them both in Danish and English because we don't make any assumptions about that people understand Danish. I have seen some other examples, for instance in Austria, where it's only available in German. So this draft also specifies that the extra text field must be discarded if the whole chain is not secure. Where I don't think we're going to see CP devices propagating the upstream DNS resolvers anytime soon, or doing let's encrypt certificates in order to be able to do a secure chain. So I have my doubts about whether or not this is going to work, but it's the current development on this. So to summarize, we have NX domains, we have CNAME or A records or Quad A that links to these stop or block pages. And then we also have some cases where it's A records or Quad A records, and all just pointing to localhost in respective address family. And then we also have empty replies in some cases. And then in some cases, IDE errors are sent. So yeah, we need something else in this HTTP block pages because it's a thing of the past. So I've tested this across RIPE Atlas with all of the probes in the greater EU area. And the majority of them don't use public resolvers, but it's pretty close. But then also the majority of those that don't use public resolvers don't do any censoring. And I think this has to do with that RIPE Atlas probes are deployed in more technical networks than usual. So there might be a higher degree of people having their own resolvers or not using ISP resolvers in any way. I have counted the ones forwarding to public resolvers as using public resolvers as well. but yeah, I'm not sure that this represents the average internet user in Europe. But there's quite a lot that is not blocked, and then there's some it's done in a variety of different ways. So it's not really consistent how this is done across Europe, even though this RT filter affects it all. And yeah, what should we do from here? Should we make some consensus on how to do this so we do it in one way and one way only? Or what should we do? And with that, I will give it up to the long queue.
So Eric, speaking as a responsibility for the DNS structure error draft, you said it's last call. It's still the last call. It's not over, right? And it's clear that there is no consensus. So expect more news on DNS today.
And yeah, I said it like that because I'm not completely familiar with ITF procedures, and also the last call that I had passed. So I would leave it up to you to say.
I mean, there's no problem, right? Yeah. I was simply to clarify the situation. Yeah. Thank you.
Thijs Mekking, IC. You mentioned the bind doesn't have RPC IDE, but of 920 they actually do. So
also with extra text.
No extra text, but
yeah. So it's the same as Unbound. No DNS dist.
Yes, exactly.
Yeah.
So Warren Kumari, Google. More of a comment than a question. The whole block pages is a really, really bad idea.
I agree.
We're trying really hard to convince government people to not do that, because all it does is trains people to click through the SSL warning. So like whenever somebody says, please redirect this somewhere, we're trying to be like, no, bad idea. Also, I think ICANN is going to be publishing like a DNS blocking document soon, which largely says similar things, like try not to do this unless you have to.
In Denmark, we often get a PDF file with you need to use this exact design on the blog page. It doesn't include HTML and CSS, it's just the PDF design thing.
Yeah, Jim Reed, freelance consultant. I've got two quick questions for you. First of all, great presentation. Thanks for all the stuff and thanks for all the hard work we've done there. I wonder if you think there's any value in trying to capture the details of the implementations that are not propagating these error codes. Not so much to say for naming and shaming, it would be good to have some kind of directory, as it were, saying version X or Y does this but doesn't do that, and gather that information. I think that'd be very helpful. The second point is I wanted to make was about your question about trying to get some kind of consensus around a standard way of handling this in an operational practice. I think that's a great idea in theory, but I think it's going to be rather impractical because DNS is just so diffuse, and the way in which ISPs and others use the DNS, it's going to be hard to see how anyone can converge around a consensus on how to do this. By all means, give it a try, but I'd be doubtful if it could actually succeed.
Yeah, thank you. Yeah, it's I ran out of time to do all of the different version tests and stuff like that. But I am considering doing a write-ups write-up of some of the details I found.
Lutz Dornhake, working for a regional ISP in Germany. First, comment on the Atlas data. As we understand the sanctions, they have to apply to broadband customers, to public. They have not to be applied to enterprise environments, server environments, and etc. So it's quite common that you have a Atlas probe in a non-broadcast or non-private household area, and that might influence the results.
Sure. Yeah. Thank you for coming.
Second point. As you mentioned, it would be fine if you have a clear indication what was the reason for blocking or for not resolving correctly, and would be fine that we have text record. But if you are going to broadband customers, there will be no security for the first resolver. So if thank for mentioning, please change it in the IETF. It will not work. It will not work for the intended audience. The next point, I am really happy to hear that there's some country in Europe which has a definite list of domain names which should be blocked. We do.
In Denmark, we have the telecommunication union that publishes all of the domains that should be blocked. I noticed on a blog page in Austria that they also included all of the domains that they were blocking on the blog page. But yeah, Mark Nottingham is also writing a draft in ITF, trying to make a public resolver or ISP resolver registry to make some reputation-based thing on whether or not the browsers would trust an error message. And yeah, that's already an extension to the draft in question.
Do you want my microphone?
Moritz Müller, SIDN, without my chair hat on. Just to comment on the censorship the Russia Today situation. We did a study on that as well, measuring the blocking of Russia Today and other of these websites in Europe at ISPs, and we saw that every country has definitely other definition of blocked domains that should be blocked. Some countries block also the mirror pages, others do not. Even within countries, there's a difference between ISPs, so it's a very messy situation because the EU basically just says, okay, you have these organization names and every country has to figure out which domain names belong to that.
Yeah, thank you. We also had recently an article in on the Danish broadcasters webpage where they had found some RT domains that were not blocked, and then they blamed the providers, and then the providers just blamed it back that the list we had gotten from the Danish government didn't contain them.
Okay, I see no more questions. Then thank you, Asbjørn.
Yeah. Thank you.
And next up is Denesh Bhabuta, and he will tell us about the DNS Hackathon update.
Thank you, Doris. Well, I'm Denesh, as she mentioned, and yes, so some of you will know me from my previous role at DNSSEC for the past 12 years. But while I'm here, yes, that QR code, I'm making use of this opportunity looking for roles. That QR code goes to my website, which then links to my LinkedIn. So if you're interested in hiring me, please have a look at that. Thank you. So it's really nice being back here in Lisbon. My first time in Lisbon was actually 16 years ago at the last RIPE meeting that was in Lisbon. So that was what, 31 meetings ago? And since then, I've been coming back regularly. And also some of you will know that I'm also the co-founder of PTNOG, and we're going to have a Kickstart meeting tomorrow if anyone's interested in supporting PTNOG going forward. So I will just give a brief update. Here's the thing. I'll give a brief update about the hackathon which took place in Stockholm on the 15th and 16th of March, a couple of months ago, kindly hosted by NetNode in their offices. So who knows what a hackathon is? Anyone in the room? Yeah? Okay, well, actually, I'm surprised not that many people do. Who doesn't know what a hackathon is? Okay, Jeff, I'm surprised. Okay, how many people have been to a hackathon? Oh, wow. Okay, that's about half and half. So for the benefit of those who don't know what a hackathon is, it's a hacking marathon. But it's all about collaboration. It's all about community. It's all about sharing, and it's actually non-competitive. It's basically working on things together. Even you may be working in competing organizations, but it's working together to make the internet better. And in this case, the DNS Hackathon was to evolve the DNS to make it better as we move forward through time. So I'd like to, well, I've already started anyway, but I'd like to start with gratitude, because it's always nice to thank those who have made this happen. So there were three hosts for this meeting. There was RIPE NCC, and the representative was Vesna. NetNode was Johanna. And then, of course, in my previous role at DNSOARC, I was a representative there. And then there were the host helpers, because the thing is that things happen over time. While the hackathon was initially discussed way back last year sometime, unfortunately, Vesna couldn't make it. So instead, we had Jerry Lundstrom from DNSOARC, who was Vesna's replacement, basically, but with less hair. And then there was Matthias Arnberg from NetNode, who was helping around. And of course, there were other people from within NetNode who were helping with the catering and everything. The program committee, of course, Arife in personal capacity, Lehman from NetNode, and Samane from ICANN. And unfortunately, neither Lehman nor Samane could be there. And so the only PC member was Arife. But it was fine because there was all this pre-work that went in, which made the hackathon possible and made it run smoothly. But of course, the hackathon wouldn't be anything without the whole group. There were about 34 people there. Collaborative. It's all about collaborative work. And I'd just like to point out that the first photo, that one over there, was taken by Johanna. But because she's also part of the group, we wanted her in the photo. So we thought, let's all look at the camera that's pointing to the group. And then you'll see Johanna there with her camera taking the photograph. So, but as I said, it's all about collaboration. And I will quickly explain how hackathons work over the next few slides. Basically, there are 3 to 4 stages to a hackathon. And the first stage is the idea stage. This is where people come along. Some people have ideas of what they want to do in the hackathon. Others think, and I'm not really sure, I'll just listen to what the ideas are, and I may or may not join a group. And so these are just ideas being written down. There's a lot of brainstorming going on. Those who have ideas are writing things on whiteboards, those who have ideas. And so over here on the bottom, far bottom over there, I think that's Willem's hand, who's writing his ideas down for one of the projects, which I'll come to later on. So that's the first stage. The second stage is to persuade people to join your group. And it's basically selling your ideas. Come and join my group. And a typical group size would be maybe 3 people minimum, 8 maximum, because that's a decent enough size to get work done within the 2 days that were there. So next one is getting the groups together and working together. You know, people get together, they will start coding, or they will write an RFC or draft an RFC, or anything else. So I just thought I'd make it full of pictures, and you can see the whole group here. So those who were at the hackathon in Stockholm, if you're comfortable enough, could you stand up, please? Yes. So thank you, everyone. Thank you for this. So those who are in the room who would like to know more about the hackathons and the work that was going on, I'll put the link up later on at the end of the presentation with a link to the hackathon page. But do make use of this time and this week to talk to the people in this room who were at the hackathon. And if you are interested in joining their projects, then please do so. Because the thing is, the hackathon may have ended, but the projects do not end. The projects continue. So if you're interested in contributing, please join the groups, contact the authors, and join them. So just very quickly, then I will go through what the projects were. There were 7 projects across 34 people. The first one, well, I'm doing this in alphabetical order. There's no hierarchy or anything. Basically the baby was delivered. It was working on NSD authoritative server to integrate Talk. And the future is to integrate not DNS and DSC. Next one was CanDNS. Creating a nameserver with CanDNS responses. And in fact, this is the most completed project, actually. And Asbjørn mentioned earlier in his talk just before mine, so there's a nice link to the previous talk, that that CanDNS would be mentioned. Now, the interesting thing is, it is actually being used as an authoritative server by Asbjørn himself already. So thank you. And then there is DHOT or Dunyan, and it's about DNS over HTTPS over Tor. The interesting thing, and the thing that I remember about this was, as I was going around between the different groups to see how things were happening and whether anyone needed any help with anything, is that they didn't actually realize that Tor is within the actual name DHOT Tor Dunyan. But I had to point that out, me being a non-techie, but anyway, I just found that surprising. And the next one, this one is pronounced idiot, because IoT devices are actually idiots. And there are various insights and recommendations on the hackathon page about what they'd found and things, so please go and have a look at those. And then there was LHB, look up hostname best practice, and it was, one of the things was making getter info better or use a workaround. But Neil is here from that group if you wish to talk to him. Actually, so is Asbjørn. Even though Asbjørn was on a different group, he still did the CanDNS authoritative himself as well. And then there was Poisonlicious. I mean, the thing is that these are really good names, aren't they? Proof of concept for an efficient DNS resolver in Unbound. And this group started drafting an ITF document. And if you download the slides, you can just click on that link. It's a safe link, by the way, so it should be okay. And then the final one was ResViz, visualizing what a resolver does when it's looking up a domain name. Actually, I'd like to go back to something because I've just remembered something. So LHB, the lookup hostname best practice thing was, the thing that was very clear from this, and what a lot of people do not know, is that DNS is more than just domain names. DNS is more than just, well, this group knows, of course, but it was something that was reiterated during the hackathon. It's more than just domain names. It's just more than address resolution. And so coming on to that, so that's all of them. So again, like I said, I will put up a link on my final slide, which links to the hackathon website. It's a GitHub page. And if you are interested in contributing, continuing to contribute to any of those, or you wish to find out more about those, please go and have a look at those. But like I said at the beginning, it's non-competitive. None of the hackathon stuff is competing against each other. It's all about collaboration, sharing, making the DNS world better, or making any technical thing better, depending on the hackathon. So the commendations, the most completed project, which I already mentioned, was CanDNS. The funniest project name, obviously, it had to be Idiot. And then there was a project with a self-appointed troublemaker, and that was Babies. And this particular person was always coming up with, actually, yes, we've done this now, but you know, NSD also does this, so maybe we need to change something, we need to look at this. And it just complicated matters a bit, but you know, they went through it. And I have this person's authorization, let's say, to mention who it is. It's actually the next speaker. It's Anand Buddhdev from RIPE NCC, the self-appointed troublemaker. So after my talk, I will welcome the self-appointed troublemaker on stage. But anyway, again, cooperation, collaboration, working together. And that's what it's about. That is a safe link, the QR code. That is a safe QR code. If you don't believe in QR codes, there's the link. But again, like I said, I'm actively seeking opportunities. Do keep me in mind. Any questions?
Hi, we have a question from the remote participant. How can we participate remotely?
So the thing with this hackathon was we decided not to have remote participation this time because one of the one was that there wasn't enough time to do it because there was something, there was a request that came in too late, and for the organizing committee it was too late to implement something like that. The nice thing about hackathons is that you're working together in the same room. And yes, there are ways of doing this. So I guess in the future, if there is a DNS hackathon, then that whatever the organizing committee, they can keep that in mind. But that will be made clearer at the time.
Do we have any more questions? No? Okay, then thank you, Denesh.
Thank you. Self-appointed troublemaker.
Yes, so last but not least, I'd welcome Anand Buddhdev. He will give us an update from the NCC about the DNS.
Good morning. I'm Anand Buddhdev from the RIPE NCC, and I'm part of the team that runs the RIPE NCC's DNS infrastructure. And this morning, I'm here to give you a short update on some of the stuff that we've been doing. So I'd like to start by telling you about our authoritative DNS. This is an Anycast DNS cloud that we operate. In addition to one of the root name servers, kroot, this authoritative DNS cloud carries various zones, including ripe.net, the reverse DNS zones of RIPE NCC's address space, as well as the reverse DNS zones of the other RIRs, and a number of CCTLDs, country code top-level domains. This is an Anycast cloud, and we have been actively adding new locations. And since RIPE 89, we've added 4 new locations to this cloud in Caracas, Venezuela, in Paris, France, in Maracay, also Venezuela, and in Taipei, in Taiwan. This is also an opportunity to invite community members to host an instance of this auth DNS, because having such an instance in your network or nearby helps to speed up resolution of the reverse DNS particularly. And as a host, you need to provide a server or a virtual server and connectivity and out-of-band access. And if you're able and willing to do that, then please look at the URL, which is on this slide, where you can find more information about the requirements. This is a map showing the various places that we have authoritative DNS instances. Not unsurprisingly, we have many instances in the European region, but absent from this is the North American region. So if there are folks here who would like to host instances of auth DNS in Canada, North America, Latin America, Africa, that would be great. The next thing I'd like to talk about is this service that we had, which we internally called ns.ripe.net. This was actually the very first name server that the RIPE NCC ever operated. And initially it was just a single name server that carried all the zones and everything we ever had. And back then, this server also offered secondary DNS for LIRs, for our members. And the provisioning process was a little bit complicated, which means that for a long time we had to keep this name around, even though many of our other services were moved off to other names. We eventually decided to stop providing this service, and we had a proposal in last year. We wrote a RIPE Labs article, and you can find the link to that article on this page. There was discussion, and the community supported our decision to withdraw the service. and we started the implementation in June last year. And on the 15th of January this year, we completed this project and stopped providing this service. The provisioning for the LIRs was done through the RIPE database, and they could create domain objects with a special attribute to request secondary DNS. And so this work involved updating domain objects. And at the start of this project, we had just over 3,500 such domain objects in the RIPE database. And we communicated with all the users by sending them individual emails in addition to public announcements. And so users began to take action. And on this graph, you can see the red line, which is the theoretical linear rate of deletion of or update of domain objects. The blue line shows what actually happened. So initially, when there was a push, lots of updates happened, and we were doing better than we had hoped or expected. But then towards the end of the year, around October, November-ish, things slowed down a little bit. And then at the previous RIPE meeting, somebody suggested that maybe we should contact not just the zone contacts, but also the contacts of the IP address space referring to the reverse DNS. And so we updated our scripts and sent out even more emails. And then there was more action and more domain objects were updated. On the 15th of January, we still had a few stragglers. There were a number of domain objects that had not been updated, despite several emails and attempts to contact them by phone. But this was the deadline, and so we updated the domain objects ourselves and completed this work. The next thing we're doing is IPv6 renumbering of our authoritative DNS cloud. This is the authoritative DNS cluster I mentioned just previously. And there's a reason for it. We currently have just a /48 prefix for this authoritative DNS service. And on the internet these days, people tend to filter at /48. And anything more specific is likely to get dropped. This means that we have no room for a covering prefix or even a test prefix. And so last year, the RIPE NCC was allocated a /29 prefix in IPv6 for various bits of our infrastructure. And we have set aside a small amount of this address space for our authoritative DNS cloud. So we have a /44 now, and we're using one /48 from this for production. And we have another /48 as a test prefix, and it allows us a /47 prefix as a covering prefix. The idea of a covering prefix is probably familiar to those operating networks and running BGP, and it allows for scenarios where if the more specific is unavailable for some reason, for example, when a customer has only one upstream and cannot reach the /48, then they can still reach this prefix through the /47 announcement. The prefixes are already configured and announced, and the DNS servers we operate are also answering. But we now need to update the names. We have to update the quad A records of the names, and we will be doing that in the coming months. And since we provide secondary DNS service for some CCTLDs, they will also have to make changes to their quad A glue in the root zone. And so this will involve some coordination with them. Statistics and graphing. For server metrics, we have recently switched to Prometheus. I will not go into the details of that. But for DNS specifically, we have been using something called DSC, which is software that was originally developed by Dwayne Wessels and is now a DNS OARC project. And we currently process XML files from DSC, and we display graphs using a very old Perl-based grapher. But now we are starting to process the XML files into Prometheus files, and we get Prometheus to collect the statistics and store them, and we can then use Grafana to display the graphs. And later this year, we will be switching away from the old Perl grapher to Grafana. Next, I'd like to talk about our DNSSEC signers. We have a pair of DNSSEC signers, Dell servers, which we purchased in 2018. The warranty is going to expire this year and cannot be extended. And we intend to continue with the same model that we have for DNSSEC signing. So we're going to acquire 2 new hardware servers. There will be no change to the operating system, the signer software, or the procedures, because that's been working rather well for us. And we continue to add and improve monitoring to our DNSSEC signing infrastructure. And with that, I come to the end of my presentation. Thank you for listening. And if you have any questions or comments, please let me know.
So do we have any questions? Anyone? No? Then I would like to thank you, Anand. Or is there someone coming? No. Thank you very much.
Thank you, Doris.
So that concludes our DNS session today. I thank you all very much for coming. Please remember to go to the BOF panel tomorrow and at the end of the sessions. And now I would like Willem to...
It's always DNS.
Yeah. So with that, I think everything is said, and you can go to the break now. Enjoy.
right. So, all right, good morning, everybody, and welcome to the IoT working group session today. So I'm Peter Steinhaeuser, co-chair of the IoT working group session. My colleague Peter Werle could not attend in person today, so I think he's still trying to get online and join via Meet Echo. He had some technical issues, but he will be with us later, I think. All right, a quick look at the agenda. So we have some very interesting talks today. I'm really excited about that. But let's start with a little bit of introduction and housekeeping first. So we start with the RIPE 89 minutes validation, then have a look at the code of conduct, and also the participation instructions for in-person and remote participation. So I also want to welcome all our remote participants. I'm really happy to see that the ranks are filling here in person, which is great. All right, so the RIPE 89 minutes have been approved. The link is on the slides, so if you want to reread it from Prague, please feel free to do so. Yeah, the code of conduct. So we're trying to feel everybody welcome and accepted here. Please be polite, treat others with respect. Even if you have conflicting opinions, we can deal with that like educated people and not losing our manners. For the attendees participating in person, after the session, during the QA of each talk, go to the mic, ask your question, please. Before asking your question, say your name and your affiliation so we can record this properly. For our remote participants, here are the instructions for Meet Echo. Our colleagues are monitoring the QA part of Meet Echo, and then we'll go to the mic and read the question so we can answer this properly. Okay, and with that, we come to our first talk. And I welcome Anna Maria Mandalari from the University College. And I'm really excited to see her here. Thank you, Anna.
Thank you, Peter. Thank you. Today, I'm going to talk about something that is going on in the IoT community in the last few years, that is about policy certification and verification for cybersecurity in the Internet of Things devices. You may be familiar with some of the regulations we will talk about today. We have a great agenda. So first of all, I want to talk about the reasons why regulations and standards are needed nowadays for Internet of Things devices. Second, I'm going to give you some example on privacy and security issues on Internet of Things devices that we found in our lab at University College London. Then I'm going to talk about some solutions, how we can automatic testing these devices to be compliant, some standards that are going on in Europe nowadays, what are the current gaps, and conclusion. So let's start with the problem. Why you should be worried to own an Internet of Things devices nowadays. For the ones that attended the RIPE meeting in the last years, probably you are now familiar with the IoT taskbed that I direct. We have hundreds of Internet of devices located at the University College London, from smart speakers to camera, fridges, more than 200 devices. And we have a copy of these devices also in another laboratory in US, in Northeastern University. And what we do, what we did since 2019 is collecting all the traffic that these devices are exchanging over the internet. And we have also the capability of interacting with these devices, like remotely trigger the activities of these devices to a central or more than one central server for which we can connect directly to the devices. So today I will give you just some example of privacy issues that we found for these devices. We have many, we had many publications from 2019. One of the latest one from privacy is the reasons why you shouldn't watch televisions. So the motivation is that in the past, there were a lot of papers on tracking and advertising services located in your smart TV. And we want to know actually if this was true and how smart television behave with respect to a new technology that nowadays is developed to into many smart TV. This technology is called automated content recognition. How it works? So basically your televisions and all the televisions that you own, because this option is enabled by default on your smart TV, take screenshots of what you're watching for many times per second. So usually you can watch television using different services, right? Netflix, linear TV, the antenna, fast TV, like for example, channels that are provided by Samsung or LG, external devices, or screencasting. What happened is that with this new technology, automated content recognition, an automated content recognition client is installed by default on your smart TV. They take screenshots of what you're watching, and then this screenshot is hashed and then sent to their automated content recognition server, a database of contents where they match what you are watching. So they can create a unique profile for you, knowing if you're interested in sports, shopping, or travel. The reason is that then they will be able to serve you the right advertisements in other channels. I will know now with AI in the future also through the smart television itself. So what we wanted to know is how frequently does automated content recognition capture snapshots of your viewing activities. And for doing that, we developed a methodology for which we installed 2 televisions in US and UK from Samsung and LG. We discovered that they capture screenshots, videos every 500 milliseconds for Samsung and audio snapshots every 10 milliseconds from LG. So we set up an experimental infrastructure where we could capture all the traffic, and particularly the traffic that is going to automated content recognition servers from the televisions in 2 different locations. And we wanted to know if when you are opting out to automated content recognition practice, actually the service is stopped, what are the automated content recognition servers that are contacted, if they are in the same country where you're watching the televisions or not. And we did this in UK and US. So we saw that automated content recognition is used for most of the services that you're using. And the most worrying part is that Smart TV records your screen, even when you use the television as a dumb devices. So even when you are connecting your laptop through an HDMI cable in television, they are still taking screenshots of what you're watching, that in the case is private information. Luckily, when you are opting out the service is stopped for both Samsung and LG. So at least they are in line with GDPR for that. We also did a comparison across the UK and US, and we noticed that for some services, some application installed in the television, the automated content recognition is stopped automatically. For example, Netflix, probably because of copyright, is stopped, but only for UK, not for US. So then we contacted Netflix to understand a little bit better what was going on, but they didn't reply. Now, so this is just an example of how smart devices can use your data. And probably, I'm sure that none of you knows that this content, this service is enabled by default on your TV. So as soon as you go home, just go to your privacy policy and disable it, because it's there by default. Now, this was just an example of privacy issues, but there were many other issues that we found with privacy for smart devices, like, for example, devices, cameras sending the MAC address unencrypted over the internet, some personal identifiable information unencrypted over the internet. We found, for example, a motion sent to some third-party services in overseas countries with respect to UK. So if you're interested, just go to my webpage and you will find many of these works in 2019. Now, privacy is not the only issue. There is another issue that is security for Internet of Things devices. And now I want to talk of just one of the latest security issues that we found with some smart medical devices. So this here, you will get another reason why you shouldn't use smart medical devices. Nowadays, you can wear and buy these devices, wearable medical devices everywhere. So you go to Amazon, you buy these glucose sensors, you install in your skin, the sensor is connected to your phone, and they can be used in an open loop, meaning that they are connected via Bluetooth Low Energy to your phone, or in a closed loop, meaning that these devices can be connected directly, for example, in the case of a CGM, that is like a glucose sensor, directly to the insulin pump. So we call this closed loop. In this case, these devices, this sensor measure the sugar in your blood, and then they regulate the insulin that will be injected in your body. Okay, so these devices, most of them, they use Bluetooth Low Energy. What we did, we set up a mini testbed. So first of all, we bought these devices. We set up a mini testbed with some of Bluetooth adapters. The cost of the second one was like 13 pounds on Amazon. The cost of the first one was like 40 pounds. But in any case, normal Bluetooth adapter. We were able to do many attacks, unfortunately, on these devices. Sniffing, man in the middle. We could do data manipulations. We could stop the devices from working. We could do reply attacks. So what we did, as you may know, Bluetooth Low Energy have a lot of security issues. But when it comes with these devices, some of the issues can be solved by, for example, just an example, changing the session key every time you are reconnecting with the devices. We discovered that this is not happening for the majority of the devices we tested. So for example, for an oximeter, we were able to manipulate the data. For ECG sensor, we were able to inject an LT report. For the case of like a blood pressure device, we could emulate hypertensions, even if this wasn't the real data from the devices. But the most worried one is really the CGM, the glucose sensors. We weren't able to do manipulation of data, but we could easily do DOS attacks on the devices, so we could stop the device to work. And you understand that if we are stopping the device to work and you are in the range, and you can be in the range, so we did the experiment in the maximum range of Bluetooth Low Energy, that is 100 meters in theory, but 25 meters in practice, we were able to stop the sensor to work. This means that if it's connected to an insulin pump directly, you can potentially kill someone. So this is our experiment results. We tested many devices, and we could, the green tick is the attacks that we could successfully perform. Don't do this at home. This is just an explanation. We did a responsible disclosure to these devices, manufacturer. Some of them, again, didn't reply. Some of them reply and said that they will replace the device in future updates, but still the devices that we test are in the market, unfortunately. So we need regulations, more regulations on these devices. We really need security by default for these devices. How can we do this? Luckily for us, we live in a country that is full of regulations. They love to do regulations in Europe. So they release and approve the European Cybersecurity Act. Now, what is the European Cyber Resilience Act, in my personal opinion, at the moment is a big mess for IoT manufacturers. Why? So if you are not familiar with it, this is a regulations that will be enforced in 2027. There is really minimum time for implementing it for the IoT manufacturers. Any Internet of Things manufacturer that sell in Europe, any devices will need to be certified. 90% of the devices can have a self-assessment, can be self-certified. 10% of the devices will need to go through a third-party assessment. They need to have like a third-party certificator. What is the problem is that if you read the 440 pages of the regulation and you are a technical person, a developer, you won't understand one word. You don't know where to start. How can you be compliant? So there is no other way than getting a fine in this case, right? And it's the same for third-party certificator. It's still not clear how this will be implemented. Who is the third-party certificator? As a developer, as an IoT manufacturer, where I need to go in order to get this certification? How much it will cost? It will be super expensive, right? And then you're also familiar with the wonderful GDPR, because probably you read the 40 pages of privacy policy that you have every time you're installing a new devices in your home, etc. So also GDPR need to be enforced, and we need for these regulations more automated tools to be implemented, and we need help. We needed to provide something that will help the developers and the IoT manufacturers to be compliant with these devices. But not only that, also the enforcement agency. Like, for example, in UK, the Information Commission Officer, they are just releasing guidelines for Internet of Things devices for Internet of Things manufacturer, but for them, in all the interactions that I had with them, it's always complicated to really enforce GDPR. You see this with the smart televisions, right? If they're doing something that is weird or circumventing the regulation, it's very complicated for an enforcement agency that we are talking about only 120 people working there, right? To enforce regulations in 22 billion of devices that we have out there nowadays. So at University College London, we implemented a system that allow hopefully to have automated compliance. There is a lot of work to do on it, but an example can be IoTrim++. So in the past, I presented in this very working group, IoTrim, that is a system for detecting non-essential destinations. So this is about privacy, non-essential destination for a device. So if a device is contacting X destinations, how many of these X destinations are actually used for the device to work? And in the past, this was a semi-automated methodology for which we took the devices in the lab, block all the destinations one by one. If blocking the destination, the devices was still working, this means that the destination is non-essential for the device to work. Now what we did, once we had the list of domains that are non-essential, maybe we thought we could build a machine learning model on the network traffic for the devices. So every time for a specific device, we see a new destination, automatically we may be able to detect that the destination is essential or not for the device to work. And this worked very well for some of the devices, or if in the training model you have, while you're training the model, you have the data from the devices in the model. So this means that the model, in this case, needs to be device specific. So you need a model that will work for the same manufacturer. It doesn't matter if it's, for example, an Amazon Fire Stick or an Amazon Alexa, but it needs to be trained on the data from the same manufacturer because they have similar behavior in terms of destinations contacted. Regarding security, you may be familiar with this standard that was released by AIDE a few years ago. These are a sort of requirements that Internet of Things devices, particularly consumer Internet of Things devices, needs to follow in order to be more secure. So how can we take these regulations, convert them, regulation or guidelines or standards, convert them in something that can be measured by just using the network traffic? So defining some active and passive tests with the network traffic that can be deployed in order to test the devices with respect to that requirements, and then produce a report of certification for the devices with respect to the requirements that are listed in the ETSI standard in this case. But this methodology could work potentially for any regulations or any document that is written in legal language. So we did this for some of the requirements that are in the standard. An example is that one of the requirements is that the devices must not have open ports that are not used by the device. So the questions here is, it will be easy, right? The methodology will be just do an nmap scanning, open port scanning, you have a list of open ports, then you check how many ports are used by the device, and you're done, and you compare the list. But there are many problems in terms of research. For example, one of the problems we have is like, how much do we need? Because we want to do this in the IoT gateway, in the router, right? So the question is, for example, for these specific requirements, how much time do we need to observe the behavior of the devices in order to have all the open ports that are used? Or for example, if you have a device that is streaming content like smart TV, this is completely different from a smart bulb. A smart bulb may have 1-2 ports used because it's using only one protocol for one purpose. Smart television's streaming content, you can install app on it. So you have different requirements for different devices. So we are doing this study to understand if actually it's possible to convert these regulations in something that you can use by looking at the network traffic. Now, so we saw a big problem here, right? We have from one side, Internet of Things manufacturers. From the other side, we have regulations, the Cybersecurity Act, and in some way, IoT manufacturers needs to be compliant with these regulations. And this is why the European Commission decided to have standards. So when you are in doubt, create another standard. And this is what happened. So there is a standardization effort for the European Commission regarding the Cybersecurity Act. Now, this standardization effort is given from the European Commission to two standardization bodies, ETSI and CENELEC. ETSI will be responsible for the technical standards, specification for ICT. CENELEC will be aligning, integrating standards into the EU regulatory framework, developing harmonized standards for the cybersecurity compliance. What is the problem with this is that there is no time. This standardization effort needs to be ready by the end of 2026 for some of the standardization requests. And some other vertical standard needs to be ready by 2027. But in any case, really the time is tight. And when I was reviewing these standards and the efforts that is done by this organization, I saw that there is a big gap here. That again is how to link these standards with what it's really needed from a developer point of view. Again, you look at the standard, the requirements, and you don't know where to start as an IoT manufacturer. So IoT manufacturer and also small, medium enterprise, they need help for this. There is a big gap of how to implement this standard. So how can we create a standard? And I was thinking that this is actually not an answer, but a question for you. How can we create standard based on network behavior of Internet of Things devices? So if you are interested, we got some funding, thanks RIPE, for helping with this standardization effort. So if the final goal of this is like create open tools for SME, for Internet of Things manufacturers that will help them to be compliant with the Cybersecurity Act. So open tools like the example, the ones that I described before around one of the requirements of the standard, like open ports. And this will be an open source repository where we can put all the tests that can be done using the network traffic, for which then IoT manufacturer can demonstrate that this compliance with the Cybersecurity Act. It's not an easy job, but I guess that if we work together, this can be done. So please help on this. If you are interested, get in touch. Now, so what's next? We really want to make compliance easy, even that your light bulb could do it. And in order to do this, we are developing this system, these softwares, and these active passive tests to be able to use them directly on the IoT gateway. So we needed to optimize the resources that we have there, because you know very well that the routers, they have limited resources, few mega RAM, and CPU is very limited. And then we need mitigation, so real deployment and evaluation. And we need to understand the problems of third-party certification. So we need to work together with policymakers, of national cybersecurity agency, to understand how and who in each country is going to do this certification and how this certification will work. Maybe we will need a standard also for certify the certificators. Who knows? It's something that I'm thinking about. And another thing I want to propose is privacy and security label certification. So in the future, each devices may have. This is a scheme that not only US is already happening, and but it's not mandatory, it's volunteer, and some of the big tech like Amazon, Google, they adhere to it. The idea is like to have a QR code in the package of the device. The QR code can be scanned from the user, and the user may know the scores with respect to particular tests, let's say, on cybersecurity issues and privacy with the device. Thank you very much for your attention. Happy to take any questions.
Yeah, very interesting talk. Thank you so much, Anna. Two quick notes. First of all, I was quite scared about your first part of your presentation. The second one is maybe, I know that the chipset vendors for gateways, they are pushing for AI capabilities, and they always need something to market it. So I think the data models you created and this detection might be one of the use cases for this technology.
Yeah, probably. We cannot know, because once the data are like leaving the smart TV, we don't know what they are doing with the data once they are in their server. But we are implementing a study in which we are checking which information is served to us in other platforms if we are watching particular content. So for example, we are implementing automated methodology for logging in with the same account in the televisions and in your browser, and then check if you're watching sports, you get advertisement that it is about sports, even if you opt out for it. I don't have the results yet, but hopefully I will have the results for the next meeting.
Thank you.
Please. Hi, Alistair Woodman. So thank you for the talk. I don't think it's quite as bad as you're articulating at the moment between where the regulation is and the standard setting stuff. I'm on weekly calls with both the Eclipse Foundation stuff and the OpenSSF. The open source community has been quite active in this particular area. There is still issues with Sensenelec because they do stuff behind paywalls, but I think they're getting squeezed in that particular regard. Etsy is actually quite active and being relatively open, so I don't think it's quite as bad as you're articulating. So I would encourage you to come out and join in with some of those areas, but it was going to be very important that the appropriate sets of standards are set there. They're not going to have time to create new standards.
Definitely.
They will be selecting existing standards and trying to get them as a profile set ready. So there's work involved, but I don't think they're not going to have the time to create yet more complexity.
Yeah, this is the problem.
They have to.
It's right what you say. Etsy is quite active, and they're glad, but they are only responsible for vertical standards. So anything that is not directly horizontal standard, directly related with the digital products, Internet of Things devices. So they will take care of browsers or anything that is related with the vertical standards of the Internet, of the Cyber Resilience Act. Horizontal standard is all about Sensenelec, And I actually, working with them, I'm starting to work with them because I want to help. And I think that the standardization community for the cybersecurity attack needs more technical experts. This is what I want to say. But you're right, I talked to them, they're quite open. On Monday, I'm going to Brussels in one of the meetings from the ETSI cyber working group. So I wish I will be more involved in the future, but I wanted to open the community that there is this problem. And if you want to help, we need more technical people in the standard developments. This is what I wanted to say.
And I don't disagree with you, but I don't think it helps for people to be turning up at the moment and actually doing stuff. We don't need people running around saying the world's going to collapse, because it isn't. They're going to make things work. The more interesting challenge is whether the whole thing will be a dead letter, because we end up having this thing and there isn't any police force that's actually paid to enforce any of this stuff. So we have to be very careful about a whole bunch of other types of things, right? So the standards are the least of my personal worries at the moment.
Yeah, enforcement is also an issue. So I liked it. Thank you.
You know, Riley, pacemaker wearer and Taurus user. So I think Alistair has already covered some of what I thought I was going to ask, but essentially I had 2.5 or 3 questions. The first is, when I see complexity like this, I think, can we make a BCP kind of document which will help make it simpler? And Alistair mentioned profiles, and that's probably the way to go. The other thing is it likely to be possible to have a container in my Taurus router which will do the gateway stuff you were talking about?
Yeah,
and
good
I forget
questions.
what the third question was, but
Okay.
I know where to find you if I think of it.
Yeah, exactly. Yeah, I think having a draft on this will be great starting point. Where a draft in which we can collect all the issues and the gaps that we have with these vulnerabilities, how we can solve them as an open source community. And the second question is, so we have open source part of IOTRIM and IOTRIM++. So you may have like a software for your router that is OpenWRT written. So probably you have an OpenWRT routers, if I know you well, and then you can download the software and it will work well. It depends on the router that you have and how much RAM you have. But I guess you have, if you have like a quite. So we tested IOTRIM++ in a very powerful router, 256 mega RAM, but probably nowadays it's the ones that you find in the market easily in Amazon. So yeah, it's there and you can download it. So this is the IOTRIM part, the ones that detect the non-essential destinations from your devices. In the future, we want to open source also the part that is detecting security issues with the devices, and hopefully we will do by the next RIDE meeting.
Yeah, thank you so much, Anna. And a quick note, OpenWRT already has device fingerprinting. So maybe combining this could be an approach to address this. Yeah, thank you so much again, Anna. Great talk. Thanks. So our next speaker is Yuanyuan Zhou. I hope I pronounced your name correctly. Okay, thank you.
Hello, everyone. And today I want to present our work, the TwinGuard, which is an adaptive digital twin for real-time HTTP intrusion detection and threat intelligence. And my name is Yuanyuan Zhou, and I'm currently a PhD student from University College London, supervised by Dr. Anna Maria Mandalari. And this work is in collaboration with Global Cyber Alliance and Yokohama National University. And firstly, I want to give you some motivation about our work. And generally is that the modern IoT challenges demand the new defenses. And from the figure here, we can notice that the IoT devices are widely deployed across critical infrastructure domains, and the traditional intrusion detection systems struggle with the evolving threats. And also the resource constraints on IoT and edge devices limit the feasibility of high-weight security solutions. And another thing is that the limited label data in the real-world settings makes the supervised detection difficult. And so the real-time adaptive and explainable intrusion detection is urgently needed. And we did some research about the previous work in some areas, and the first one is digital twins in the cybersecurity. And what we found is that this concept is widely applied in the industrial content system security, but really in the web-based attacks. And there is no existing system uses the real-time honeypot data to detect this application layer attacks adaptively. And another thing is that we did some research about this wild web attack analysis, and where we noticed that the existing taxonomies are often limited to the specific attack categories, and also their previous fingerprinting work mostly focused about the source identification. And we did this, and we do the analysis about the intrusions from the wild and gives the profiling based on the behavioral characteristics and also the taxonomy validation. And now I want to give you the introduction about our work. And so generally, this starts from the digital twin framework, which measures the real attacker behavior, which is captured by the honeypots. And we use a virtual model that learns and adapts over time. And the main components about this design contain these three parts, and they are the structured sequence modeling, machine learning classification, and also the semantic profiling. And this twin guard offers a modular, lightweight, and also extensible design. And to make it more clear, and we have this three-layer design, and one is from the bottom is the physical layer, which is used for capture real-world HTTP attacks based on these honeypot sensors, and also this virtual layer, and we have the storage about the historical data, and we train this model. One is the tri-tree, which is mainly used for the path matching, and the other is the machine learning models. This is mainly used for the general intrusion detection. And when the new traffic is arriving, this will realize real-time monitoring. And when there is a need, this will trigger the retraining mechanism, and which we call the adaptive engine. And on the top, we have this intelligence layer, which has two components. One is a hierarchical taxonomy, and the other we did some fingerprinting of attack infrastructures, which is, there are two. One is the cloud providers and also the user agent. And to make it more detailed, and let me give you a more clear illustration about each layer. And from this physical layer, we mainly have this honeypot networks and also the data acquisition part. And we got the data lasting for 26 days. And this is a primary honeypot network from Proxipot, which is supported by the Global Cyber Alliance. And to test the generalization on the different input. And we also have this internal honeypot network, which is called the XPOT. This is supported by the Yokohama National University. And to note that they only have 70% of fields align with our primary schema, and which is kind of matching the real world setting, that not all the data are formatted in the same way. And for the virtual layer, this layer is mainly used for the real-time monitoring and adaptive detection. And firstly, from this monitoring, this offers an interpretable view of structured request paths by aggregating common behavior patterns. And to be more specific, firstly, we have a sensitive word extraction part. And we will reduce the granularity of the HTTP headers at this step. And when we come up with this structured path representation, which is illustrated by method to status and URL keywords. And for example, if we have the header like this, and we will get the results from the get to the status and also the keywords from the HTTP headers. And from here, we start with this path matching. And when we match an unknown path, this will add up to the unknown flag. And once this flag is over the threshold, we will trigger the update mechanism. And the other part about the virtual layer is the machine learning classifiers. This is mainly used for the general purpose intrusion detection. And we did the finger engineering here, which incorporates the basic HTTP attributes and some content embeddings, also with the temporal spatial features. And we implement with machine learning classifiers. We used the random forest and the XGBoost here, and we also tested with deep learning models, but they generally show similar results, and so we just go for the simple one. And regarding the adaptive part, we adopt this sliding window mechanism, which continuously monitors performance degradation and structural novelty within the HTTP traffic stream. And we got the label data from the proxy port, which have classifications of Stein, attempt, and intrusion control. And we define the stable periods, and one is both classifiers. The accuracy drop is less than 6%, and the unknown pattern rate is under 3%. And also for the labeling criteria, firstly, we match the similar labeling mechanism as the proxy pod to our internal pod, which are unlabeled, which is based on the structured request path, payload content, and also the endpoint semantics. And this also shows the usage of the tri-tree. We note that if there is a spike in unknown patterns occurs without the existing labels, we can check if there is new labeling is needed to maintain the general detection accuracy. And we did some measurement about the accuracy and unknown rate dynamics. And we measure the data from the window 3 to 6 days. And where we observe from here that the smaller windows show faster reaction, frequent updates, and higher volatility. And also for larger windows, we can observe a stable accuracy, fewer updates, and also lower unknown rate. And from the results here, we noticed that the 6 days window strikes a balance between the model utility and also the stable performance. And to measure with this adaptive part, and we integrate this internal honeypot on 26th of March, and where we notice there is a surge in unknown sequences and also an accuracy drop is also observed upon this integration, but the general performance of the model is recovered after one retraining cycle. And the next is about the intelligence layer, where we do the intrusion labeling and attacker attribute. And firstly, we have this hierarchical taxonomy structure, which has 3 layers. And the first layer is where we have the intrusion general categories. And on the second layer, and we have the technique to realize this kind of intrusion. And this is illustrate how this intrusion is done. And on the third layer, we have the end goals to help you understand why the attacker is doing it. And we did some attacker behavior fingerprinting, and the feature distributions are visualized using these histograms and also the kernel density estimation. And we did the plotting. This is on the user agent. From the left part, the x-axis represents different HTTP session features, and also the y-axis indicates their normalized value across the sessions. And on the left part, in order to quantitatively measure the deviations about different distributions, and we calculate this GS divergence. And from the results, we notice that they have diverse behaviors across different user groups. especially in this intrusion type. And also we notice they have high divergence observed between the standard bot, Python library. This indicates the distinct attacker behavior. And we did the same thing to the cloud providers. And here we can see from the figure, they have generally the similar shapes, and which illustrate overall low divergence. And from the GIS divergence calculation, and we noticed that for the cloud C, this shows slight divergence in the intrusion attack, but the general impact is minimal. And to verify the results from the plotting, and we map back the hierarchical taxonomy back into each group. And here is the results from the user agent, and where we can notice they have diverse distributions inside of different groups. And for example, the browser and clean tool sessions are concentrated in broad categories like exploit attempts and also web shell uploads. And for Python libraries and standard bots, this demonstrates greater technical diversity, especially in the misconfiguration and the file inclusion. And also for the cloud provider, which we verify their similar patterns here, which shows that they have a shared attack fortress, but they have some minor exploit variations. For example, for the Cloud C, we can notice they have more misconfiguration exploit, and for Cloud D, we have something more about SQL injection. And but generally, this confirms that the cloud-based attacks are likely templated and automated regardless of the provider. And so to make a conclusion, and firstly, we have this high accuracy and responsive models, which maintains the accuracy over 90% during the stable periods. And we establish this dual classifiers along with this sequence monitoring to ensure the robustness of the performance of our model. And also, we realize this adaptive retraining triggered by the novelty, and where we notice that there is a strong negative correlation between unknown rate and accuracy. And when the new integration is coming in, there is a 42% spike in unknowns and also the certain percent accuracy drop, but this is mitigated in just one update cycle. And yes, and we did this with deployment with diverse traffic, which demonstrates the adaptability across different environments. And we did this this behavior intelligence, which reveals that the diverse attack behavior across the user agent tabs. And also we noticed that the cloud-based traffic shows consistent patterns, which may indicate they have the shared tooling. And as for the future work, and firstly, I'm considering to do more with real-world deployment and evaluation, like we can integrate this with the real web traffic, all from our real IoT lab. And also, I want to expand the protocol coverage, which is beyond the HTTP, to include more protocols like SSH, FTP, and DNS. And this work is currently doing a daily based querying from the data source, but in the future, it will be able to do the continuous streaming. And also, it is worth to consider with the lightweight IoT deployment on the edge. And that wraps up my presentation here. And this work is from our lab, the SafeNet IoT, based at University College London. And thank you again for Global Cyber Alliance and Yokohama National University. If you are interested in our work, you can follow us from the following link or scan the QR code here. And thank you for listening. I'm happy to take any questions and comments.
Thank you so much. Okay, so we don't have any questions online. Any questions from the audience? Otherwise, a big thanks again. Okay. Great work. And we open the stage for our next speaker.
Thank you.
So, hi everyone. So today I'm Abhishek. I'm a postdoc at INRIA in Team Privatics. So this work was done jointly with INRIA in France and UCL. Here, so interesting story. So this work started recently in the RIPE hackathon on DNS that happened, and there we took on some problem, and it went from investigation to hopefully IMC paper in a couple of days. So in this work, we are looking up at the need of having operational and security best practices for IoT specifically. So why do we need it? So we firstly did a state of the art. So in the state of the art, we look at multiple standardization bodies. For example, ETSI, NIST, ENISA, European Commission, ISO, IEC, ITU, and more. And then the goal was to do a state of the art and check if there are regulations and do they contain, and the guidelines, and do they contain DNS? Yes. So DNS is present in multiple of those. But what about DNS in IoT? Looking at the intersection, no. So there is a clear gap of any IoT-specific DNS regulation framework or standards. And so basically, but first of all, why do we need it? So why do we need it? Because we found multiple issues. And this talk, I will just show you issues one after another. So here we go. So firstly, so one of the first issues that we saw is in the same test bed of Anna, where we have in UCL, we have more than 30 devices across diverse sets of categories, so ranging from very naive ones to sophisticated ones. And we look into what happens in the source port randomization point of view. And we look at the standard deviation. And then looking into this across devices, as you can see, we found devices which either almost don't randomize or randomize very poorly as well. So quite unexpected, but yes, we found it. So for example, a camera, Arlo camera 4 here, or a plug fails to do adequate randomization. So this was one of the first issues that we found. Another issue. So then we moved on to investigate further. So that we investigate transaction IDs in DNS. So looking at the transaction IDs, the issues were a bit more severe. So we saw devices which don't randomize their transaction IDs, which could lead to spoofing and other kinds of attacks. And then we also put basically classified into brackets of no or poor randomization, good, versus ones which are excellent. So yes, there are indeed devices which comply, but there are a significant chunk of devices, around 25%, which don't. So yes, so this was another issue that we found. And then we moved further. So next, we tried to see queries. So queries for transaction IDs across devices. So for example, a couple of examples here. So LG TV on the left and a RoboVac on the right. We look into number of queries that you do, the histogram of number of queries. And what we see is they are quite distinct. So generally, you will see multiple queries ranging from 2 to 12, even more. So and then they are quite distinct, which basically could lead to are easy targets for fingerprinting. And then we also need to see the reasons why the queries are erratic and multiple. So we investigate further. And so we already saw that queries are repeated. Yes, but how do they look like? So looking across the range of devices, we see that queries are very repetitive in nature and across devices, and some of them query a lot. So this is a 30-minute snapshot that was taken of 30 devices. So queries, so perhaps they are unnecessary. We will dig deeper, but we saw quite repetitiveness in the query in short duration. Then going further, what we try to see is the compliance part as well. So do private or secure protocols like DOH or DOT is supported by IoT devices or not? So we try to lay a testbed for that. So basically, we configured an unbound resolver supporting DOH only. And then we try to see how many devices come on board. And surprising or unsurprisingly, none of them. So we don't see any support for DOH, DOT currently in IoT devices. And but then we saw a subsidiary interesting phenomena. And what we saw is on the left, you have number of queries per device normally, and versus when they are put on a DOH support, we saw a huge amplification. So on average, 10-fold amplification of queries due to the resolution failure. So basically, that means that IoT devices are quite aggressive in their querying patterns when there is a resolution failure. So okay, so we move further and look into more issues in DNS for IoT. So here we look at, for example, packet sizes. So packet sizes distributions across in the queries across devices. If you look at it, one thing very interesting from a fingerprinting point of view is they are quite diverse. So more is the diversity, the higher is the chances to be for a fingerprint to be unique, and some of them are quite stable too. So quite robust fingerprints can be extracted from them. So yeah. So and we also already showed it in another papers that it is true. So yes, fingerprinting just from the query length is possible. So what's the solution? We already saw that DOH is not being present. So yes, we need DOH, but DOH also we need to have padding with it because of the query due to varying query lengths. So yes, so DOH without padding will still cause fingerprinting issues. So we need that. We investigate further and look into the issues why these queries were being done. So for example, we look at the context of traffic in these IoT devices. So naturally, you will think that they are going for HTTP request following the resolution, but it wasn't the case. So what we saw mostly is these devices are basically having a bunch of ICMP and things before DNS query, and then subsequent incessant queries were being done. So yes, so we are investigating more, but apparently there is not much pattern, and they go on querying and querying and querying. And yes, going further, we also looked into the support point of view from IPv6. So quite low, less than 30% of the IoT devices in the testbed did support that. And yes, and moving from the support, DOH, I already said, wasn't seen being supported. But then we saw another interesting phenomena, which was basically that some of the devices were still communicating, and that made us realize why. So we investigate further, and when we try to look into it, some of the IoT devices basically have hard-coded fallback addresses in which they fall back and keep querying, and that is present even though you have a DHCP-based assignment. So basically, without user being known, you will be going to fall back from certain devices. So that's what we saw, and the goal of all of this is to turn them into recommendations, as I will discuss next. And but looking further into issues still, we found that so next we investigated the TTL values in the replies, and looking at the TTL values, they are having quite a range, but irrespective of a device having a local cache or not, they don't abide with it. So IoT devices generally don't abide with this with the TTL values, and they query irrespective of what they receive. And a bit more, we even looked into the eDNS0 support, none found, and we look into MDNS traffic quite large in the devices that we saw, and which could lead to privacy issues in our passive threat model. And yes, so given those issues, what do we need next? So firstly, I didn't show all the results here, so this is a work in progress. So we already have so these all were passive attacks. So we sniffed the traffic passively and tried to see the compliance and vulnerabilities. But then we did a bunch of tasks with the active test. So which I didn't show, but I'll be happy to show in future. So in active test, we did 3 tasks. So we looked at the IoT devices, how resilient they are respect to malformed replies, and with respect to the injected replies. And we saw some interesting results in their query and retries. They were quite amplified. Then second class in active, we also morphed the TTL values that you already saw to extreme values. So for example, what happens if you set a 0 TTL or extreme TTL? And we saw very interesting phenomena in queries and retries. Then lastly, we also, in active threat model, we also tried to see what happens in the case of denial of service. And we basically amplified the responses, not only in terms of their number, but also in terms of their sizes. And we saw that devices are indeed affected operationally when you swarm them with numbers. And also, interestingly, also when you send a crafted reply with very large content in it, it leads to fragmentation and other operational issues, which I didn't show, but we found them. So converting these multiple comprehensive issues, we want to convert them into guidelines. What do we need? We are discussing with Anna, for example, on standards. We want to start a draft, example IETF. I will be happy to have any suggestions for any working groups, since I'm not well versed in these regard. Please reach out to me, and thank you, and I'm happy to take any questions.
Thanks, Abhishek.
Hi, Michael Richardson. So I just published a RFC 9726. It's about DNS and IoT devices, but it's a little more forward-looking than I think where your document that you want to write is perhaps more remedial. But it's about one of the advice there. It's about doing dumb things with your DNS that would make mud files hard to do. So that's a little bit more forward-looking than we are at, unfortunately. As to which working group, the IoT Ops working group has been rechartered, and your content would be very welcome, and I'd be happy to co-author. I had a question when you did all the surveying, and you said there was some DOH, and if I understood you right, what you said is that there were devices that did not use the DNS that DHCP or whatever told them to, and always use DOH, or it was only fallback if there was nothing available?
No, just fallback.
Okay,
Yes.
so what you're saying is that all the other devices you tested used the DNS servers you told them to?
Yes, and
that's really fantastic, because that's for many people that they do not want their IoT devices, you know, talking elsewhere, and they also want to be able to do threat detection and signaling by observing DNS requests. So I think in that space we're in a really good place, because they haven't jumped on DOH and just going to 888. There is some evidence that, for instance, Google Chromecasts would keep using 888 even though you blocked it and you know, gave them local DNS and whatever, and they would keep coming back and trying it, and you're like, no, 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 I do not want you to ever do that. Well, you know.
Yeah, we saw in very few, but you're right. It's good in many regards that they don't.
Yeah. So please come to the IoT Ops Working Group, and
Yes.
as it's recently rechartered, and this would be most welcome.
Thanks a lot, and I will be reaching out. Thanks.
Hello, thank you for the presentation. My name's Sam Cheadle from ICANN. Very interested in the fingerprinting based on the characteristics, DNS query volume or packet size. One thing that wasn't clear to me was whether those were more predictive or more useful features for IoT devices in comparison to conventional network devices. Is that something you've looked into?
Yeah, so looking into them, we saw that queries, in terms of their length of queries and the frequency, is quite unique in IoT devices. Like when you do clustering, you can almost get clear clusters into them. So that's the first thing we saw. And second thing that IoT we were very much interested specifically in was operational point of view. How does how does all these vulnerabilities and all these kind of attacks, mostly in active domain, affect the operational point of view? And in the active attacks, we did see, which we are writing, like around 35% or something devices are affected operationally too. So that's something that we. Thank you.
Okay, then we don't have questions online. Thank you so much, Abhishek. Great talk. Thank you. So next is Michael. So please go ahead.
Hi, and this is the clicker, right? Okay. Hi, I'm Michael. So I'm talking on two topics. This microphone's really weird. But okay. And they're related, but they are different topics. You prefer I use that one? I don't know. It's just so weird that it has two pieces sticking out. I don't know where to speak. There we go. All right. Yeah, that's better. Let's do this way. Okay, so I'm going to talk a little bit about the Device Identity Forum, the IETF SETL potential working group, an effort that was called the Secure Usable Internet Browser, and a little bit about some updates to the IoT Ops working group. And I would be happy to take as many questions as you have. So Device Identity Forum is an entity that is actually starting tomorrow, a little bit after lunch. I'm sorry for the overlap with our meeting, but there was much negotiation of the time, and that is when the inaugural meeting wound up. And so I'm the chair. What is it? So the IoT, well, I'll talk about the IoT Security Foundation in the next slide. So this is an entity that is designed to do, as I said, about 60% technical marketing, okay? And we'll be going over this tomorrow, and I'm happy to share my slides if you don't make it there. And the two URLs on there are collect a bunch of the things. There's a press release that we announced last week at Cyber UK. And, you know, it's about communication about things, and fundamentally it's about making sure that every device has an identity. So who's the IT Security Foundation? Is formed in 2015. They have an annual conference, UK based but worldwide. Dr. Mandalari is now on the steering board as of, I don't know, a year ago or something like that. There's a lot of good stuff there. It is an industry forum. It is not too market oriented, but it does do at a level of marketing and involvement with regulation. So, you know, if this was the, if we were comparing it to the RIPE and IETF, they are at a higher, a less technical level for sure, do not intend to really create standards, but on the other hand, they've done a lot of security best practices and self-evaluations and other things like this that are often closer to legal documents and regulations than they are to standards. So it's an interesting group to be involved with, you know, it seems like a good place to do this work. So what's this forum about? So device identity is a cryptographic, you know, a strong identity that's installed to the device. They are ideally installed at the manufacturer in the factory. They are ideally in 802.1AR IDEV ID, but there are other notions. They can go into your secure element, to your TPM, your virtual TPM living in a trusted execution environment, or not. As far as I'm concerned, if you have a, you know, little tiny device that has a, you know, 100K of ROM or something like this and is basically sealed, when maybe it's secure enough physically as it is. You can use them to sign evidence for remote attestation, and you can use them, and this is where I care about it, you can use them for onboarding devices. So pretty much every single onboarding mechanism, whether it's Brewski, OPC UA, CSA Matter, FIDO IoT, all of those depend upon the device coming with an identity in it. And over 10 years of developing these things, we've received various pushbacks from PLMs and other people. Oh, this is hard to do. My factory can't do it. It's impossible. And in at least 2 cases, I've told the PLMs, I've said, you know, your devices already come with them. You just didn't know because no one thought it was important enough to tell you. It was assumed. So this is what it's about. It's about making sure that we're sharing those success stories with the whole industry, making it clear that it's easier than they thought. And at some level, you know, at some level, just creating a good Visio stencil for a certificate. I saw one presentation yesterday or the day before, I guess it was, where they use the traditional diploma icon for a certificate, only it was a trust anchor, not a certificate. And explaining that kind of stuff in a visual way, in a common way across industry is actually something that I think we're lacking, and I think one of the reasons why it looks really complicated, particularly to non-technical managers. They're like, oh, what is it all about? And it's like, no, it's not that complicated. You just didn't understand it because the presentation was poor. As I said, it's required for pretty much any onboarding protocol that you want to do, you have to do that. And I hope eventually it will make fingerprinting obsolete because you'll have a much stronger definitive notion of what this thing is. So what are we going to do? Well, probably a bunch of white papers about success stories, some presentations, some common material, you know, as I said, Visio stencils or SVGs for your presentations, some common, you know, things so that when people go and talk outside of kind of our in-group, but facing outwards, that the message we're sending is common and people who see it more than once go, yeah, oh, I remember that. It looks visually similar. The messaging is similar. Okay, you must be talking about the same thing, right? And at some point, we'll have to do something with quantum safety and that stuff. So please sign up. Even if you don't make it, please sign up because then you'll be in the database. There isn't a great deal of signing up. You can unicast me, that's fine, or hand me your business card or whatever. And we're hoping to have also just kind of regular, as I said, success story talks and discussions that maybe will be under chapter house rules, but I don't quite know how to do that with a recorded online thing. We'll figure out how that's going to do. So I actually could stop there and ask you any questions, or you can come back at the end as you wish. Anyone raising to the mic? No? Yeah, please, just do it here. That's the back button. Yeah, there we go.
So, hi, Abhi from INRIA. So I worked a bit on device identities across BLE, Wi-Fi, and LoRa. We proposed randomization techniques. We even broke them and stuff like that. So when you talk about identities, are we also talking about randomized identities, and how secure are those identities? Are they adaptive enough, or in what context, really?
Well, I'm talking about, in this case, about an identity that's put in the factory that strongly identifies the device, what kind of type it is. So, for instance, some of the regulatory things that Professor Mandalari was talking about, it's impossible to actually know if the device complies to the regulation if you don't actually know what it is. And I'm also concerned that manufacturers will present one device to the regulator, right, that maybe has more RAM, more ROM, blah, 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 right? And then will actually fill the supply chain with a cheaper, simpler device that does not do that, right? And so it's a bait and switch. I predict it will happen. And device identities are one way to deal with that, so that end users actually can say, what is this device? You said it was going to do this. Did it do this? Well, this device doesn't, right? So that's a separate conversation from what does the device, if it talks to the cloud or something that would be visible outside of the home or enterprise, what identity does it use that would be visible over things? That maybe needs to be different. And sometimes we call those operational certificates rather than identity certificates. And if you do TLS 1.3, client-side mutual authentication, then you can hide that anyway, right? But, you know, there's kind of back and forth. So my opinion is that mostly that outside of keeping the identities of the devices invisible over, say, Wi-Fi to an eavesdropper who's not part of the network, my opinion is that everyone is better served by knowing exactly what it is, and that it's your refrigerator talking to the world and not your TV doing ACR, okay? That's better for all of us than trying to obscure that things. Having made sure that, you know, someone sitting on the street can't tell what you have because you've got some good, well-encrypted Wi-Fi, and you're not using, say, MAC addresses that are predictable, which are visible even in encrypted Wi-Fi, right? So does that answer your question, that I'm sitting on the fence here?
Yeah, it's quite clear. Thank you.
Yeah, okay. Anybody else? Yeah.
Neil O'Reilly, and somebody told me once that there's no such thing as a stupid question. So here's an attempted counterexample, because I'm totally ignorant here.
Yeah, are you up to it?
I don't know. You can tell me. Is Yang relevant here?
Is Yang relevant here?
That's
Yang.
the question.
Yeah. You know, it's not that stupid a question. Unfortunately, you failed. Try again. So the answer is that if you were going to create IoT devices that were manageable by Yang, which I don't think you will see in the residential home space ever, okay, but let's say they're air conditioning systems in this hotel, that would be, to me, reasonably that there would be a Yang module that you could manage it. Then the answer is that whatever management system that reaches out to it is probably going to want security, and the device is going to want to identify itself correctly. So think about a TLS server search on the device. So the answer is the device identity, the birth certificate's probably wrong for that use, but the birth certificate lets you onboard it into your system which then lets you provide an operational certificate to the device. So that's how Brewski, OPC UA, CSA Matter, they all do that mechanism. They onboard the device based on the device identity, and then they provide a new enrollment certificate to the device so that now it can be, yes, managed over RESTconf or CoreConf or what have you.
Rüdiger Volk, kind of following up on this, I find the idea surprising that you assume that there is no management. And if there is management, well, kind of, it's a long time ago that strange devices like toasters were SNMP managed. I think there are other devices out that are doing this right now. And if there are devices that are managed by SNMP, I would think
sure.
Well, okay, kind of, they would have a MIB, and MIBs should be replaced by Young.
So you're completely correct, and that's why I caveated it in an enterprise or hotel or something. I would totally expect that. The question is not, is Yang useful in the home for the device? The question is, does the home have a manager that speaks Yang out there? Okay, and the trend is no. Okay, so the CSA Matter mechanism has their own private information model that they use to manage devices, and it's not Yang. Okay, so alas, it's their own thing. Go talk to Google, blah, 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 blah. And OPC UA, for instance, is an industrial protocol, and they have their own information model, and it goes back to, well, 1995 with Corba, if you remember that space. Yes, that's how I feel, Holger, too, about that. But, you know, they at least are using TLS now and not their own RSA mechanism. Okay, so I'm going to go on. So IETF related things. So there is a proposal to create a working group called SETTLE, Secure Access to TLS Local Resources. It's got a proposed charter. It probably won't have a BOF. It might be live by Madrid. It's the result of several people kind of reinventing or rediscovering the problem of how do I speak HTTPS to a device in my home. Given that it has no public name, it has a RFC19 address, and my browser puts up, you know, ridiculous, crazy warnings because if it did have a certificate, it would be wrong. So the question is either how do we get certificates into such devices with trust anchors, or how do we do something that's not TLS, or how do we make browsers that maybe have more interesting properties, and which one it is still open to debate. And we had presentations maybe two years ago at RIPE at this thing about the secure usable internet browser, which the project that came out of IUTSF, and so did IoT Ops, and we've been back and forth on this, and we don't have there isn't a real answer at this point. There is a conversation and a tussle, and I'm inviting you to participate in that. That's what I'm trying to update you about. And as part of that, you should know that the IoT Ops working group was rechartered. It can now do some more protocol work as opposed to just being a dispatchy-like thing. And in particular, device lifecycle. So discovery of software updates, which is not in the mandate of the suit working group, but also the software update might not be in the suit format, but you might prefer to have them all on a server in your network, and you know, all 12 of your light bulbs or all 12,000 of your light bulbs in this hotel don't need to reach out to the internet to get their own copy of the firmware, for instance. And at the end of their life, you might want to kill them and remove all, you know, the credentials on them, and you might want to be assured that that happens before you put it in the dumpster, because someone may retrieve the device and discover something you didn't want them. And it is now the official home for MUDwork. So it's moved from Ops AWG, which was a problem. And we have an RFC 7228 BIS, which is much expanded, and your comments would be most welcome with that. And that was it. And I'm exactly out of time? Yeah, there we go. Yeah.
Thank you. So any questions to Michael? Otherwise, thanks a lot again for a very entertaining and informative talk. Thanks, Michael. All right, this brings us to the end of the working group session for today. So, as you may know, the term of my co-chair, Peter Werle, ends by today. And I wanted to thank him so much for stepping up 2 years ago with the situation that we didn't have a candidate and he was spontaneously jumping in. And I'm really grateful that he served the working group for those 2 years. So a big thanks to Peter. He's online. So thanks, Peter. So during the process of finding a new co-chair, on the mailing list, Professor Anna Maria Mandalari volunteered, and the members of the working group, they gave her very strong success. So by the charter of the working group, I'm very happy to announce that Professor Anna Mandalari got selected as the new co-chair of the IoT working group. So thank you so much for volunteering and for your openness to serve the working group. Thank you so much. And then, like unfortunately passed away person tended to say, there's one more thing. So I was asked to just remind you the NomCom will hold office hours during the second half of all lunch breaks from 1:15 to 2 p.m. And they are in the room Castañer to speak in person to the committee, to arrange for separate meetings with committee members. And you can also share feedback on ICP2 from 1:30 to 2 at the meet and greet desk. And with this, I want to thank all the attendees today in person and online for this session, and a big, big thanks to our presenters today. It was a really informative and great session, and I'm grateful for everyone who attended and helped. Thank you so much.